click bell button.
In this video, we are going to see about converting block diagram into signal flow graph and finding transfer function by using Mason-Gaines formula. So this is the given block diagram. First we have to mark the number of nodes available in the given block diagram. So now we can mark first input is 1. Next we can consider this as 2. Then this is 3. This is 3. This is 4. This is 5, this is 6, this is 7, this is 8. So now we have to draw the equivalent signal flow graph for this block diagram. So now, this is the starting point of a signal flow graph. Its input value is R of S. So now this is 1. So 1, 2, 2. So here gain is, we can consider as 1. Because there is no gain, it means it is 1. So next, from 2 to 3. From 2 to 3 also there is no gain, therefore unity gain. So at this point, here this is 3. So from 3 to 4, you see from 3 to 4, its gain value is G1. Therefore, its direction is from this point to this point. Therefore, direction is from left to right. Therefore, its gain G1 direction is left to right. Next, this is 0.4. So now from this 4 to 5 there is a gain G2. Its direction also from left to right. Therefore here G2, this is 5. Now from 5 to 6, its direction is from left to right, and 6, this is node 6. From 6 to 7 there is no gain, therefore so here gain G3. So from 6 to 7 there is no gain, so we have to mark it as unit gain. Next one is, we can consider as output, that is 8. So now, so apart from this straight, so next we have to complete the remaining areas. So now we can take this loop. So now from 2 to 7, it is connecting 2 to 7. So it is a parallel branch. It is not a loop. So it is parallel branch, because so this direction are same way, but these two are parallel. Therefore, it is connecting a parallel path from 2 to 7. Its gain value is G4. Its direction is from left to right. Therefore, this is the direction. Next, after this G4, next we can complete this. So this is from 6 to 4. But we see it is a feedback. So it forms a loop. So 6 to 4. 6 to 4. Its direction is from right to left. Therefore, we see this is the starting point. Again it is coming to the same point. So now we can consider this is a loop. Its gain is H2. Apart from this, one more path here. So it is starting at 5 and ending at 3. So we have to start at 5 and end at 3. So here its gain is H1. This is actually from 5 to, arrow mark is 5 to 3. Therefore, this is the correct arrow mark. Its gain value is H1. So now there is one more point here that we can consider as node number 9. So here 9. So therefore 9 to 3, it is connecting with positive. Therefore here plus 1. But we see 9 to 4, it is connecting with minus. Therefore here minus 1. Similarly, we see this H2 is connecting with minus. Therefore, while summing here, it will be added with minus H2. Therefore, here we have to use H2. You see, here plus, therefore, simply we used plus 1. So here plus, therefore, simply we used G4. But we see at this point are minus. Therefore, here we have to use minus H2 in signal flow graph. So here there is a unity gain, but in signal flow graph we have to use minus 1. So this is the signal flow graph for this block diagram. So next we have to solve the signal flow graph and we have to find the transfer function. According to the signal flow graph concept, first we have to find the forward path and its gain. So we know this is the given problem. So actually it is starting at 1 and it is moving to 2 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. Actually from 1 to 8, it is moving from left to right. So now we can consider this is a forward path. Its gains are 1, 1. This branch gain is G1, G2, G3, 1, 1. So its gain, this is the first forward path. Its gain is multiplication of all individual branch gain. 1 into 1 into G1 into G2 into G3 into 1 into 1. Therefore, finally G1, G2, G3. Next, this is the given problem. So from this next to parallel path is, so this is the starting point. Then 1 to 2 it is forward from left to right. Again there is a branch here. It is moving from 2 to 3 from left to right. And finally it is reaching 8. Therefore, it is a next second forward path. So this is the second forward path. Its gain is 1 into G4 into 1. Therefore, second forward path B2 equal to G4. So this is first forward path gain. This is second forward path gain. Next step 3, individual loop gain. So now we have to find the individual loop gains. So this is the given problem. We know loop means it has to start and end at the same point. We know this is not a loop because its arrow marks are same direction. Therefore it is a parallel branch. But here we see this is a fourth node, this is sixth node. From fourth node to fifth node, sixth node, and again it is reaching fourth node. Therefore this we can consider as a individual loop. So now we can draw here. This is the first individual loop. 4, 5, 6. This is gain of its individual loop. So this gain is G2, its gain is G3. So now we can say P11. So first individual loop, its gain is multiplication of these three gain. Therefore G2, G3, H2. Next, after this, so we see if we consider this point 3, from 3 to 4, 4 to 5, again it is coming to this point. So now we can say from 3 to 4, 5, again it is coming to 3. Here one more node, that is 9. Its gain value is H1, its gain value is 1, 1, 1, its gain value is. This is the second loop, second individual loop. Its gain P21, second individual loop gain. P21 is G1 into G2 into H1 into 1. Therefore G1 into G2 into H1. Next, from this diagram, third possible loop is, so we see from 4 through 5 and 9. So we can draw here. This is 4, this is 5, this is 9. So through this there is a closed loop. Its individual gains are G2, H1, minus 1. Therefore this is third individual loop. Its gain is B31 equal to G2 into H1 into minus 1. Therefore G2 into H1 into minus 1. Therefore minus G2 H1. So next gain product of 2, 3 and 4 non-touching loops. Actually totally there are 3 loops only. We see it is, this loop is involving node 4. This is also involving node 4. So this is involving, so this is node 4. So we see all 3 individual loops are involving or touching at a point or node 4. We see this is touching at node 4, this is also at 4, this is also touching at 4, or going through this 4. Therefore all 3 loops are involving the same node 4. So there is no 2 or 3 non-touching loops in the given problem. Therefore no possibility of two or 3 non-touching loops. So in the given problem there is no possibility of 2 or 3 non-touching loop. Next one is step 5, calculation of del and del k value. So we know del, to calculate del is 1 minus sum of individual loop gain plus sum of 2 non-touching loop gain minus sum of 3 non-touching loop gain. So in the given problem, there is no 2 non-touching or 3 non-touching loop gains, only individual loop gains. We already calculated. So del equal to 1 minus P11 plus P21 plus P31. Remaining terms are 0. Therefore, del equal to 1 minus G1 into G3 into H1. Therefore, 1 minus G1 G2 H1 plus its gain is minus G2 G3 H2 plus minus G2 H1. These three we already calculated. Simply we have to substitute here. So we will get del equal to 1 minus G1 G2 H1. So minus into minus plus G2 G3 H2. Again minus into minus plus G2 H1. So this is the del value. Next we have to find del K. So del K means, so we know for del K formula is 1 minus part of graph which are not touching forward path K. So therefore to calculate del 1, so here 1 minus actually first forward path. So this is the first forward path. It is involving 1, 2, 3, 4, 5, 6, 7, 8. We see all loops and branches are going or meeting all the nodes in this forward path. It means here there is no separate path. Therefore del 1 equal to 1. Next del 2. For del 2 1 minus, we see this is the second forward path. So this is the second forward path. Excluding this part is a, excluding this forward path, there is a separate path. Therefore 1 minus its gain. So first if we take this loop, its gain is minus G2 G3 H2. Next loop is, this is next loop. Therefore plus G2 into H1 into minus G2 into H1 into minus 1 plus next, this is the next loop. Its gain is G1 G2 into H1. So now, so next transfer function. So we calculated del value. This is the del value. Next we calculated del 1 value, del 2 value, P1 value, P2 value. So according to Mason-Gaines formula, transfer function T equal to 1 by del, sum of K equal to 1 to K, Pk del K. So here there are two forward paths. Therefore we can expand this formula 1 by del into P1 del 1 plus B2 del 2. So now we have to substitute all of this value. Therefore transfer function T equal to, so now del is, so this is del value. This will be in denominator 1 minus G1 G2 H1 plus G2 G3 H2 plus G2 H1. Next P1. So P1 value is G1 G2 G3 into del 1. Del 1 only is 1. Therefore plus. Next P2. P2 value is G4 into del 2 value. So we have to multiply this G4 with all of this term. Therefore we will get G4 minus G1 G2 G4 H1 plus G2 G3 G4 H2 plus here G2 G4 H1. Substituting del P1 del 1 P2 del 2 value, we will get the final transfer function T equal to G1 G2 G3 plus G4 minus G1 G2 G4 H1 plus G2, G3, G4, H2 plus G2, G4, H1 divided by this denominator term.